Okay, now let's go with the second practical exercise. So in the second practical exercise, what we have to do is we are planning on something called urban green spacing. So typically, Urban Development Authority in Sri Lanka, they mandate and mandate that every resident should live within 1.5 kilometers of a public park. So they should be able to access a public park properly. So now for this one, we are going to assess how many or how many uh, uh, Gram military divisions in Colombo district are lacked lack on this simple criteria. So for this one, we will need like two data sets, actually three, GN divisions and then population and then parks. So we will have to do the partial join and then we will have to do some erasing and then we will have to identify the green desert areas and then we will have to do a simple calculation. For the same thing, for this one I will open arc map quickly. Same thing, I have already downloaded the data in here. So if I go into the practical 02, I have the dataset GND, parks and population CSV file in here. So let's see how we can do this analysis. To do this analysis, I already created a document in here, the steps that you have to follow. In here, mention. So first things first, what we have to do is we have to create the coordinate system. Here either you can use the UTM 744N. Typically what I recommend is to use Andhavala coordinate system, and then we can follow along with the same thing. But in here I forgot to mention, you have to do the calculation, you have to do the population density calculation before you going ahead with this practical. Where's my arc map? Is it loaded? Yeah, I will close this one, open a new window, same procedure going on here. Click and put a folder connection. Okay, go to the location where your folder is. Practical 2. Okay, and click your database. Rack 02. This add, then okay, file, save as, go to the practical 02 folder, give it a name, track 02 mxd and save. So always remember, you need to have these two files in the directory where you have the data. So after you finish your exercise, you have to like zip these two files, like select these two files, right click and compress, and then upload or hand it over after you're done with your practical, during your practical session, the practical part of your examination. Okay, now we have linked and we have all the data set. I will go to the catalog. Same thing over there in the top. I will load the Gram military divisions. I will add this into the map and then parks. We'll add all the parks layer in here and then the population CSV. So if I right click and open the properties in this one, the coordinate system is in WGS. So first things first, what we have to do is we are focusing on not any other places, we are focusing on Colombo. So what we have to do, we need to clip. We have to clip two files, all the GND file, GND boundaries in Colombo district and also the parks which are only located in Colombo district. So what we can do, we just went to the R.M.Dinesh shape file in here, right click, open attributes, and then go to the filtration, select for admin2 those adm2 name equal, get unique values, and then click on Colombo and hit apply. So now you will see all the GND files which were located in Colombo district has been selected. After that, what was the tool we have to use? Clip. So we have to search for the tool clip in analysis and then type here R.M.Dinesh and then again R.M.Dinesh, the output will be GND in Colombo. I will type this one as GND Colombo and then click OK. Okay, I have the R.M.Dinesh divisions clipped. I will remove the total one. So here you can see we do have the parks all around Sri Lanka. Now we need to clip the parks. So we will use the same thing, clip analysis. Input features we will use park, clip features we will use GND Colombo, and then this one I will type parks Colombo and then click OK. So now I will remove the rest of the parks from here. We'll remove this one. Now we have to check whether we do have a population density field in here in the attribute table. So let me go ahead and see whether we do have that field, as I think we don't have. Yeah, we don't have the population field. So what we have to do, we have the population CSV file, right click, display X and Y, X axis on Y axis, click OK, add to the layer, OK. Now we have to clip this point data set as well. Clip analysis. Population CSV, clip features, GND in Colombo. This is population of Colombo. And then click. After that thing is also clipped, we can remove this population information. So next what we have to do, we have to join. We have to do this partial join part to get the number of people or the total population in each R.M.Dinesh district. So what we have to do is partial join. Is partial join, search for the tool is partial join analysis. For the target features, what we are going to say, GND Colombo, and we are going to join the populations in Colombo, and then this one we will say GND Colombo pop, and then 1 to 1. Scroll down for the population, right click, merge rule should be sum, not first, not last, not minimum, not maximum, not count. It should be sum, total points, and then the rule should be contains, completely contains, and then click. So after that we can remove GND Colombo from here, and then even population in Colombo, because we have get the population values into the GND files. If you open the attribute table of GND Colombo.pop, you will see the population column in this location. Okay, now what we have to do, so if I go to the properties, now we have to do the conversion. Right now we are in the GCS, that means geographic coordinate system. So we cannot do calculations like especially planar calculations using this one. So we have to convert this one into projected coordinate system. So what's the coordinate system that we are going to use? Kandawala. So what's the tool we are going to use? Projection. Go over there, project, data management, select JND Colombo pop, then JND Colombo pop projected, select the coordinate system, Kandawala. So projected coordinate system, national grid, Asia, Kandawala, Sri Lanka grid. Click OK and hit OK. So now I will remove this file. Now we have to do the projection for the parks as well. Parks in Colombo, and then parks in Colombo projected output coordinate system. Now you already have the Kandawala over there, so I will select Kandawala grid and click OK. Now those two layers has been converted, so I will remove this one. Now we have to do what? So we have to open the attribute table and do the calculation. We have to get the density. So to calculate the density, what we have to do? We have to add a field name area. So it should be double, and then click OK. Go into the area column, click over there, right click, calculate geometry, click yes, and then the square kilometers, and then click OK and yes. So you have how many square kilometers are over there. Now we need to calculate the population density. So I will type density. So you can type pop density and select the type as double. Go over there, right click, calculate field, yes, and then how to calculate the density? Population divide by area. Click OK. So now you have the population density over there. Now what we have to do? The population density is there. Now what we have to do? Now we have to do the magic or the calculation. So how we can follow along with the calculation? So if you go to the practical, here I mentioned, and some of the things are not there. You have to verify the population data. So population data was not there. So we added the population data. Now what we have to do? We have to calculate the nearest parks using this partial join method. Before that thing, we have to convert this uh, polygon data set into point data set. So we have to find the centroid of each GND division and even the parks. So first I will convert the GNs and then I will convert the parks. So to convert the GNs, what we can do? There's a tool named feature to point. Open this tool, search for this tool and click on this feature to point under data management, and then input features. You can input GN pop, and then here you can give it a name as GN centroids. So I will give it a name GN centroids, and then you have to tick in here inside optional. That means inside of this each polygon the centroid should be located. So no matter what, from every boundary it should be in the center. So after I click OK, you can see centroids for each GND district has been created. Now we have to convert the parks as well. So for this one also I will select the parks Colombo, and then this one I will type parks centroids and then click OK. So now I do have park centroids and GN centroids. So if I zoom into this one, you can see there's a park in here, and for the park also we do have a centroid. So if I click on this inspect item and then click over there in this small dot, you can see it's in point. So last time these park values are in polygon, now everything is in point. Even if I click this small point, you can see it's Borella North GN centroid. So now we do have the centroids and the parks. So now what we have to do? So now if we go to the document, we have to say perform the closest spatial join. So how we can do the closest spatial join? So there's same thing. We have to search for the spatial join tool. Search for the spatial join tool, and then targeted features. So which feature we are going to target? Definitely we are going to target it GN centroids. We are going to target GN centroids, and then join feature will be our park centroids. So the output we can give it a name GN distance to parks. So I will give that layer name GN distance to park, and then join the operation mode is 1 to 1, and then here where the magic is going to happen, match option we have to say closest set. We have to find the closest, and then here we have to give a name, distance field name. So distance field name is optional, but here we have to give it a name. So we can copy and distance to park in meters. So we can create this new column by giving it a name, and then here instead of decimal degrees choose meters and then click OK. Okay, now if you go into the DN distance to parks, open the attribute, and then you will have the distance from each centroids to the parks in here. So you can see these velocity and these GN divisions are farther away from the parks. So the closest ones are these. There are some parks which are very close. Madivela we do have, Keselwatta, Kajugahavatta, Bodhi, Rajapura, Vellavatta, Utura. So we do have closest park over there. So now what we have to do? So for the next thing what we have to do is phase 3, we have to identify the green deserts where we don't have the facilities in the GN divisions. So for this one we have to do the buffering part. So we have the hint from the question that UDA recommends mandates that every resident should live within 1.5 kilometers of a public park. So we have to do the buffering for all the parks. That means park centroids to be in 1.5 kilometers away. So how we can do it? So we can search for the buffer tool. Of course, the buffer tool we have to select, and then click on GN centroids. So here we can say, we can give it a name, parks within 1.5 service area, and then we can put the unit 1.5. It should be in kilometers. Instead of this one I will say parks in service area 1.5 kilometers. Then this all method should be planner, and click OK. So we should have buffer zones around the parks with 1.5 kilometers. So I think I made a mistake. So I didn't select the parks in here. Of course, I didn't select the parks. So let me remove this one and go back to the tool. What's the tool? Buffer. Here I have to select the park centroids. And then parks in service area 1.5. It should be in kilometers. This all type all and click OK. So these are the areas that are covered from the parks. Now we do have the areas which are covered from the parks. Now we have to remove these areas and get the rest of the area. How we can get that thing? We discussed about this tool. You have heard about the erase tool. So now we are going to use the erase tool. Search for the erase tool and analysis. And for the input feature, what we are going to do? We are going to give the GND Colombo layer, GND Colombo population projected layer, and then erase the features. That means we have to erase parks in service area. So we are going to remove this area from this Colombo GL file, and then we are going to save this one as the green deserts. So these will be the desert areas or the areas which we don't have any parks under the coverage. So after tool run finished, we can like remove these all the layers, and we can see all the rest of the area has been cut off from the map. So if I remove these points, now you ended up with this cut off green desert areas. So how we can identify the top 3 priority location? Now we just need to open up this green desert file, and if we go into the open attribute table, and if you go into the very end, we will have the population density. Of course, we have to focus on more population. So if the population is high, if it is not covered in that region, we have to focus on that location. So if I click here, so it is this specific GN, but the problem is part of that GN is covered. So we can remove that GN, and then for the next one, if I go and check for this specific GN also, it's also covered from a park. So we can skip that one as well. So the next one, okay, this GN also covered by a specific park. This one, if I inspect, is also covered from a specific park. So the next one, yeah, this GN is totally covered, and then next, this GN is not covered. So it's like farther away, but we have a higher density. So we can select this one as a candidate, and then for the next one, it's also covered. So keep in your mind which one we do have for the polar waste. You can either copy this information and paste it over there. Which Gramanildari locations we have to find. So the polar waste, and then this one, it is covered. So if you see, this part is covered, so no need for that one. For this section also, it is covered by a park, so no need. This GN is also covered. This one is also covered. This one also covered. this is not covered, but we can say we don't need to focus much more on this GN division. So this one is also at the very end, but it is also very nearby, and is also covered. This is also covered, so we don't need to focus, but if you want, we can consider. It totally depends. We are just giving the suggestions. And then this GN is also covered. This GN is also not covered. So we should be able to allocate a park for this specific region as well. So they want to the west. So then you can write the report. So how you can write the report? You can write based on the analysis of population demand, lack of accessibility, recommend that the 3 new public parks to be special high priority locations are within name of GN Division 1, that means Suwarapola West, and then name of GN Division 2, Bangalavatta, and then the name of GN Division 3, Deltara West. So you can write a simple sentence like that, as well as you can visualize that on a map. How you can visualize that thing on the map? So if I say this, and I can go into these green desert maps, I will go to the properties, and then from there, under the symbology, I can go to the categories, quantiles. I will go to the quantiles, graduated symbols, graduated colors. I will go with the graduated colors. For the values, you can select population density, and then you can classify this one. I will classify into 6 classes. Natural, I will type quantile and click apply. Okay, and click OK. So you can see it's better if we can also allocate some parks in these regions as well, because this region doesn't cover any parks. So most of the areas in here it's covered from the parks, but we can consider like these kind of locations as well. Now you can use this map and show and visualize. So parks in service areas, this one you can say I will give this one a color as like green. That means these areas are totally covered with the parks, and these are the regions that we need to cover. So for this one also you can create a map and give a title, legend, north arrow, and scale bar, and then you can even export the map. So this is how you can complete this exercise.